This is LeetCode house robber. And if we're given an input like this, the answer is going to be 4 because we know that we can rob this house, and they're not adjacent, and that's the maximum value. To check all possible combinations will be very slow, so let's go and see how we can get a better solution. The first bit of intuition here is we can break this problem down into bits. We know that we can rob this house, and then not this house, and then these houses. And what we can do is do the same algorithm for this part of the array. So really, you could break it down like this. So 1 plus 3 and 1. However, this isn't the full solution because we can also have this 2, and then not this 3, not this 1, and then we can have this 1. So an alternative here is 2 plus same algorithm for 1. And we want to get the maximum value, so we're going to take the max here. So it's the max of these. So this is the recursive solution to the problem, and it works pretty well for small arrays, but for large arrays, it doesn't work well. So imagine we're given this array 1, 2, 3, 4, 5, 6. Our first step will be getting the maximum of 1 plus this, and 2 plus this. And this is our second step here. And what you'll notice is that there are some repeating elements here, namely these two, 6 and 6. In this case, it's not so bad because we can actually just return the element if the array is only length 1. But if the array were even larger, there would be more repeating elements, and the algorithm would redo the same calculations over and over and over. Instead of going from the whole array and going smaller and smaller, why don't we start with the small array and build up? So we're actually going to start from the right side here first, and we're going to build backwards, because if you notice in the algorithm before, when we start from the left, it continuously uses the right elements. So we need the right elements to be done first, and then we can go to the left. Okay, so for now, we'll just use a hash here. So if our algorithm were only going to get 6 as the input, the answer is clearly 6. If our algorithm were to get 5 and 6 as the input, again, the answer is 6. If our algorithm gets 4, 5, 6 as the input, this is equal to the max of 4 plus whatever's in the hash at 6 and 5 plus empty hash. And then we do this again. So now we say 3 all the way up until 6 is equal to the max 3 plus whatever's in the hash 5 and 6 and 4 plus whatever's in the hash for 6 and so on and so forth. By the end of this algorithm, we'll have the whole array in our data structure and we can just return that. And so that's the basic idea. We build up, bottom up until we get all the way back to the end on the left side, and then we just return that number. And our data structure here is actually going to be very large because we'll be storing multiple arrays in it. So an optimization is instead of using a dictionary or hash data structure, we can actually just use an array. So it would be the array at 5, which is the index of this, and the array at 4, then the array at 3, the array at 2, etc. So in terms of time complexity, this algorithm goes through each element once, and it's just an O of 1 operation because it's either going to return a number immediately or it's going to return the max of 2 numbers. That's just an O of 1 algorithm. So time complexity is O of n, and space complexity, because we're just basically going to be storing an array, or you can store the indices in a hash instead, that's going to be O of n as well. Now, before we get to the code, if you found this helpful so far, please give a like and a subscribe because it really helps the YouTube algorithm. And let's get to the code. All right, first we'll define our rob hash, which will be just an empty hash. And actually, we're going to be using a default dictionary here. So from collections, we'll import default dictionary. And so this will be a default dictionary of 0. So each element, if it's not initialized, will just be 0. And then we'll get the end index, which is going to be the length of nums minus 1. And now we'll go and do our loop. So for I in range end index, we're going to go all the way to 0, and we're going to decrement. And now here's where we do our max. So the rob hash at I is equal to the maximum of nums at I, this is our current number, plus rob hash at I plus 2, and nums at I plus 1, plus rob hash at I plus 3. There we go. And then we just return rob hash at 0. Now there's a little bit of an off by 1 error here because nums at I+1 will be undefined because we're starting at the end index. So we actually have to start from 1 before the end index, and we need to define rob hash at the end index, which is going to equal just the number at end index. So in our previous example, when we had 1, 2, 3, 4, 5, and 6, rob hash at 5 will equal 6. And now this algorithm can work. And we got the right answer, and it's faster than 76% of online submissions. And that's it. So if you found this helpful, again, please give a like and a subscribe because it really helps the YouTube algorithm. And I'll see you next time.